In this video, I want to discuss 6 different ways we can authenticate using the AWS Terraform provider to AWS. And these 6 ways are outlined in the AWS Terraform provider documentation, and some are more secure than others. So for this video, I have created 6 different files here, each containing different provider configurations or ways we can authenticate using the AWS provider. I've got a folder here called Terraform Code, and in it I have just a simple VPC resource that I would like to create in AWS. So the plan is, for each example, I will take one of these files, move it into the working directory where our Terraform code exists, and we will examine the authentication there. Our first example uses the provider configuration, and this is where we configure authentication credentials within the provider block of the AWS provider. This is not recommended, and HashiCorp even calls this out on their AWS provider documentation in big red letters, stating hard-coded credentials are not recommended in any Terraform configuration and risk secret leakage should this file ever be committed to a public registry. If someone were to put their access key and secret key here and push it to GitHub, your credentials are compromised. So what we need to do is we need to fill in an access key and a secret ID here. So I'll go ahead and do that now. So for access key, I'll provide that. And it's worth noting that after this video, these credentials will not exist. So do not try them. You'll be wasting your time. And then I can save it, and I can move that into the Terraform working directory. I've got a leftover file here I can delete real quick. And now I'm ready to run a Terraform init to initialize my Terraform configuration. Now that Terraform has been successfully initialized, I can run a Terraform plan. And this is when I will know if my credentials are correct. When you run a Terraform plan, the provider will reach out to the API for that provider and authenticate with the credentials. And because I've been able to return a plan here, I know that I have successfully authenticated to the AWS API. The second way we can authenticate with the AWS Terraform provider is through the use of environment variables that we set in the runtime environment wherever we execute Terraform. Instead of hard coding these values in the provider block, we just set them as environment variables. So I'll do that now. I'll go ahead and export each one of these into my environment. And if you're on Windows, the command for creating environment variables is different. So please take note that I am on Linux. And now that I've set these, Terraform will use this information in my environment rather than the configuration block to authenticate to AWS. So I can leave my provider block just like this, empty. I can move this file into my Terraform working directory. And when I run a Terraform init, I'll successfully initialize and run a Terraform plan. And because I have a successful plan, I know that I have successfully authenticated. But this time, my provider block had no knowledge of what my access key ID and secret key were. Instead, the provider pulled those from my environment. Our third option for authenticating with the AWS Terraform provider is to use what's called a shared config file and shared credential file. Using these, we specify the location of a shared config file, the location of a shared credential file, and a profile within these files that we want to use. So you would be familiar with these files if you're familiar with the command AWS configure from the AWS CLI, right? You run it and asks you for an AWS key ID, an AWS secret access key, a default region, and how you would like to output these things. Once you've done that, right, if you go to your home directory, you get a file called .aws. And if we go in there, we can see we have a config and credentials file, and those correspond to our shared config files and shared credential files. And if we open them up, we see the config file has our region and output, while the credentials has our credentials. So we have two options when we're doing this. We can specify the location of the config and credentials file, assuming they're not in the default location. And we can also specify the profile, because if we look at one of these files, they'll both specify a profile here in brackets. By default, it's specified as default. So if we don't specify a profile, the AWS provider will automatically use default. And we can also leave the provider block blank and not set environment variables, and our provider will source those credentials from this file because it is the only place they exist. So to demonstrate that, let's first go with this example here. So we'll go ahead and we'll comment out this, and we'll move this file into our Terraform working directory. And we know that this is the path that we need to use. So here I will insert the path to the config file and the credentials file. And we want to use the default profile. I'll save that. And now I will go back to this directory and run a Terraform init. But first, let's remove those environment variables that we set in a previous example, so we can ensure we're sourcing credentials from these files and not from our environment variables. So I'll look for those environment variables, and I'll go ahead and unset AWS region. I'll go ahead and unset AWS secret access key, and I'll also unset AWS access key ID. So now those environment variables no longer exist. So we'll cd into our Terraform working directory. We'll run a Terraform init. And then before I run a plan, I'll go ahead and configure my configuration and credentials file. So I'll do an AWS configure, or you can put these directly into the file. All this does is edit those files for you, so you don't have to open them up. And now we'll do a Terraform plan. And when we return a plan, we will know we are using our credentials from these files. And there we have it. Now there is a way for us to tell exactly where this provider is pulling credentials from. And that is by setting an environment variable called tf_log, and we'll set that to debug. And when we run a Terraform plan, we get a more verbose output. And in this output, depending on how you have your provider configured, it will tell you where it is sourcing credentials from. So when this plan finishes, and it's finished, we'll scroll up a little bit, and we will see here, using shared credentials file from configuration, using shared configuration files from configuration. So we know that this is what the provider is using to authenticate. Now, remember how I told you option 2 here would work as well, as long as we use the default profile. Because if we don't provide these options, and Terraform cannot find this information to authenticate in an environment variable or set directly here, it will look in this file by default. So by leaving this blank and not having our credentials set anywhere else, when we run a Terraform plan, it will use those credentials as well. And we will let it finish here. And we'll scroll up and we will see that we have retrieved credentials from our shared configurations file in the directory specified, but we did not tell the provider where it was. It by default looked there and looked at the default profile because it couldn't find credentials in environment variables or set directly in the provider block. So another authentication method made available to us if we are utilizing the Terraform AWS provider on certain AWS services such as AWS Codebuild or AWS ECS or AWS EKS is to not provide the credentials inside of our provider block, but to instead let them be pulled from special environment variables set by those services at runtime. So, quote from the documentation, if you are running Terraform on Codebuild or ECS and have configured an IAM task role, Terraform can use the container's task role. This support is based on an underlying AWS Container Credentials Relative URI and AWS Container Credentials Full URI environment variables being automatically set by those services or manually for advanced usage. And then we have similar verbiage for EKS using different environment variables. So what does that mean to you? Well, I'll demonstrate this with AWS Codebuild, and then the concepts will be the same. You'll kind of understand how that would work with ECS or EKS. So I've taken our code here, our VPC code, and if I switch over to AWS, I've created a code commit repository, and I've gone ahead and uploaded the same code, just a VPC that we would like to create. And then I've created a provider.tf file, and I haven't told it how to authenticate with AWS. And then I have a build spec.yaml that Codebuild will use to run a Terraform. So we will download Terraform, run a Terraform init, and run a Terraform plan. But notice nowhere in here am I asking for credentials or secrets. I'm not pulling them from anywhere. So that's the code. So real quick, I'll go ahead and make an edit to this. And I'll go ahead and commit this. And that'll kick off a build for me. So I'll come over to Codebuild, build projects, and we'll just keep refreshing this until it's triggered that new build, and there we have it. Now that my build has succeeded, we can go to the bottom of the logs here, and we see we have a successful Terraform plan. And that means we have successfully authenticated against the AWS API. But remember, we didn't set any credentials. We never told the AWS provider who we were and how to authenticate to AWS. So I want to demonstrate that special environment variable that gets set automatically by the AWS service at runtime. So we'll go back to our source code here, and we'll go to our build spec, and we're going to edit this. And real quick, I'm just going to add a quick command here to print our environment variables. And this is going to give us an output of all the environment variables. That's not even a real email address. And now we'll trigger a new build. So we'll go to Codebuild, we'll go to our project. We'll get a new build here in a second. All right, and we will wait for this to finish. Now that our build is complete, we can scroll down to our environment variables that got printed out. And we can see they're all here, and these were all set by AWS Codebuild at runtime. And here we have one called AWS Container Credentials Relative URI. And this is one of the ones that are called out in the AWS documentation, AWS Container Credentials Relative URI. So we can see that the Codebuild service has automatically set this environment variable to look at this specific URI and pull our credentials out for use with the AWS Terraform provider. So we don't have to tell the provider when it's running on Codebuild our credentials. We don't have to store them anywhere because AWS will take care of that for us. And you can also use this environment variable within your build spec.yaml tasks to manipulate this further if you needed to. And so it's the same similar concept when you're using ECS or EKS. It's just going to be different environment variables for EKS as opposed to the ones you would use for Codebuild or ECS. So another way we can authenticate with the AWS Terraform provider, and my favorite way, is through the use of EC2 Instance Profiles. So if you're running Terraform from an EC2 instance, like I am here, so I've created an EC2 instance, and as you can see here, I've SSH'd into it, and I've created my Terraform files, my vpc.tf, which is just the resource VPC that we've been using, and the provider.tf. Right, and you can see the provider is empty, right? And I've already done a Terraform init here, but if I try to run a Terraform plan, it's gonna not work because I don't have credentials set. And it can't find them anywhere, not in environment variables, not in a credentials file, not through an environment variable, right? So what are our options? Well, we can provide an EC2 metadata service endpoint here, or we don't have to. We don't have to provide anything as provider block once we assign an EC2 instance role. So let's see what that looks like using an EC2 instance role. So if I go back, real quick, I'll go to IAM and I'll create a role and I'll choose EC2. And what this will do by choosing this, it will create alongside this IAM role an EC2 instance role. If I don't do this, I'm not going to get that EC2 instance role. And I just need to give it the ability to act upon VPC resources because that's all I want to do. And then we'll just call it EC2, if I can spell EC2 instance role. And we'll go ahead and create that. So if I click on it, you'll see here I now have an instance profile ARN. I don't have to configure the provider at all. What I can do is I can come back to my instance. I can go to Actions, Security, Modify IAM role, and I can assign that instance role. So I've now assigned that EC2 instance role to the EC2 instance. So it has an EC2 instance profile. So if we come back to our EC2 instance, right? You can see I'm not doing anything different. I'm just going to run a Terraform plan again, but this time it runs successfully. And then just to ensure that, nothing went crazy, we'll go back to our security. We'll select the instance, go back to security, modify role, no role, update that. We'll detach. And then we'll go back to our code and we'll run Terraform plan again. And we can see it fails. But we haven't configured our provider with any credentials. What happened is the EC2 server used that EC2 instance profile to configure those resources. And I've gone ahead and run this plan again with the EC2 instance role provided, and I've also set the Terraform log environment variable, and we can see in the output that we are now retrieving credentials from the EC2 role provider. The other way, and the final way I want to go over, is through the use of assume role in the AWS provider. And what this is it's a way for us to take a user in one account, have them authenticate with the AWS provider, and then have them be able to assume a role from another AWS account to do things against that account. So it's not so much an authentication method like all the other ones we've covered. It's an additional method to authenticate to another AWS account to gain certain permissions, if that makes sense. So to demonstrate that, right, first you have to authenticate as the user that you want to attempt to assume role with, right? So here I have two AWS accounts. I have IT infrastructure and the sudo one. So the sudo one is my user, and I want to attempt to assume a role that exists in IT infrastructure account. So that means first I have to authenticate as the sudo one to AWS, and then I can attempt to assume role. All right, so I've gone ahead and configured my credentials that the AWS provider will use to authenticate to my to the sudo one's first AWS account. Now what I need to do is I need to come over to the IT infrastructure account, and I need to create the role that I would like to assume, right? So I'm going to be attempting to create a VPC, do a Terraform plan at least. So I need to create a role for that. So if you choose AWS account, you can say I would like to create a policy that allows another account, right? Grab that account ID. And then we can provide an external ID, and we should provide an external ID. And this is basically a password that the user from the other account attempting to assume a role inside of our account needs to provide as a basically like a passphrase, a secret to let you assume the role. So we'll do lead code. We'll do next. And we want VPC full access. And we'll call it third party assume role. And we'll create that role. So this is the role we're going to attempt to assume. Now, if we look at it, the trust relationship is what tells us who's allowed to attempt to assume this role and what external ID do they need to provide. So by default, when we provided that account ID, it said the root account is allowed to assume this role. Well, we don't want that. We want the sudo one's account to be able to assume this role. So let's bring this over a little here. And it's a little hard to read. But we're going to go to the sudo one's account real quick. And users. Oh man, this is killing me. And we're going to go grab the sudo one's ARN. And then we'll come back to our policy, our trust policy, and we'll replace that with the sudo one's. So now we're saying the sudo one from that account is allowed to assume this policy as long as they provide the external ID leak code, right? So that's great. So now we can grab this role ARN because that's what we would like to assume. We can come back over to our code. We can paste that in there. We need to provide the external ID. And I'm in the Terraform working directory. My provider, my assume role.tf with the provider information is in the Terraform working directory. I've already run a Terraform init, so now I'll run a Terraform plan. And I've got debug on, the logging. So that's why we're getting a very verbose output here. And plan successful, right? Now, how do we know we're using the assume role? Well, if we look back up through the logs here, right, it says, you know, retrieved initial credentials from the credentials file. So that was earlier when I did the AWS configure. Assuming the role, right, and it passes in that information, the ARN, the external ID. If that wasn't successful, we would have gotten an error, right? So we know we've successfully authenticated as the sudo one and then assumed a role inside of another AWS account. And if you don't remember, that environment variable to get that verbose log is tf_log, and then you can do any logging level, you know, debug, trace, info, what have you.